Welcome to this tutorial. I'm solving question number 7 of paper 21 October-November exam series of 2021. There are two parts in this question where we are given with a choice. So I'm solving the first one here. It says figure 7.1 shows a solenoid connected to an ammeter. So we have a solenoid over here, the coil. Then we have an ammeter connected across it, so it would detect the current if there is any current in the coil. And then we have a permanent magnet which is moving towards the coil. The S pole of a permanent magnet moves into the left hand end of the solenoid. The ammeter reading shows that there is a small positive current in the circuit. Explain why there is a current in the circuit when the magnet moves. So the reason is because of the movement of the magnetic field lines cut the coil, so there is a changing magnetic field in solenoid. So when there is a changing magnetic field across a conductor, we know that an EMF is induced in the conductor, and because of this EMF the current flows. So I'm writing which produces the current, and because of this current there is a reading on the ammeter. The next part says when the magnet is inside the solenoid it stops moving. It is then pulled back out of the solenoid. Explain what happens to the ammeter reading as the magnet moves out of the left hand end of the solenoid. So we have negative reading of current, because initially when the magnet was moving towards the coil we had the positive reading of the current, and now we would have the negative reading of the current, because and the reason for this is the magnetic field lines are cut in opposite direction as compared to the one that was being done before. So when the cutting takes place in the opposite direction, the opposite EMF or the EMF with opposite polarities is induced, and because of this EMF opposite current or the reverse current or negative current flows through the coil. I would be solving question number 7 which has a choice, so I'm solving the second part which is related to the logic gates. It says figure 7.2 shows the symbol for a logic gate and its truth table. So we have a symbol over here and it is an OR gate which has an inverter applied to its output. So when the both inputs are 0, the output becomes 1. Otherwise, the output remains 0 when either one of the input is at logic level 1 or both are at logic level 1. So simply they are being ORed first. So we have this output when we apply the OR gate to the inputs, and then we apply an inverter, so every output is inverted. 0 becomes 1 and 1s becomes 0. Now the question says state the name of this logic gate. So it is a NOR gate, an inverter applied to an OR gate. Figure 7.3 shows two of these logic gates connected to make a bistable circuit. So we have a NOR gate over here where a P input is being applied Similarly, a Q input is being applied to the second NOR gate. The output of this first NOR gate is again input at the second NOR gate, and the output of the second NOR gate is again input to the first one. The output of the first is called X, which becomes an input for the second one. The output for the second becomes Y, and it becomes an input for the first one, or the upper one. Terminals P and Q each have logic level 0. So we have a logic level 0 here and here. Terminal X has the logic level 1. So we have 1 over here. Explain why the terminal Y has the logic level 0. So it is 0 because when Y becomes 0 and it becomes an input to the upper NOR gate, the output would become 1. And if it is not 0, for example it is at 1, then this would also be 1, and 0 and 1 would give us the output as 0. So it cannot be 1 unless the Y is at 0. So both the inputs for the upper NOR gate become 0 and the output becomes 1. So now we have to explain. I'm writing Y is an input to the upper NOR gate, and it has to be a 0 for the output to become 1. So since the output of the upper NOR gate is 1, the other input also has to be 0. The next part says terminal P is briefly connected to a supply of logic level 1. State the effect of this on the logic level of terminal X and the logic level of terminal Y. So now the terminal P is briefly connected to 1. So I'm changing it and this terminal becomes 1. Now when this becomes 1, the X would become 0. So this 0 would become the input for the lower NOR gate, and when both the inputs are 0, the output of the lower gate would change into a 1. So I'm writing the answer here that X changes to 0 and Y changes to 1 because of this change. The next part says terminal P returns to logic level 0 again. State the effect of this return to 0 on the logic level of terminal X and on the logic level of Y. Now for this part, P again changes to 0. So we have a 0 here at terminal P. Now the other input received by the P has now changed to 1. So there are two inputs because this output changed to 1. So this would become the input for the NOR gate, and when 0 and 1 are applied at the input, we have the output still equal to 0. Now this 0 would be applied over here. So both the inputs for the lower NOR gate are 0 and the output would remain 1. So it means that there is no change taking place for the X and Y when P is changed to 0. So I'm writing the answer: both stay the same and do not change. So the next part says state how this circuit exhibits the property of memory. So the circuit shows that the output shows which terminal last had the value 1. So this is how it exhibits the property of the memory. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.